So the next question in front of you is given as the following, that is coefficient of a to the power 6 b to the power 4 c square is in the expansion of the following product. So first let us write down the product as given as ac plus bd to the power 6 and 1 plus
factorial 8 divided by.
So the next question in front of you is given that the coefficient of a to the power 6 b to the power 4 c square in the expansion of the following product. So this is ac plus bd to the power 6 and 1 plus a by d to the power 8. So first let's write down the product. The product given is ac plus bd to the power 6, 1 plus a by d to the power 8. So this is the product, the coefficient of which we have to find out. First, let us write down the general form of this equation of this product, that is 6CR AC to the power 6 minus R BD to the power R into 8CK A by D to the power K. Now we are given the okay, first let us write down this in the expansion form, that is 6CR into 8CK into A to the power 6 minus R plus K into, let's write down B. B is B to the power, do we have any B? Only one, so B to the power R into C to the power 6 minus R, any more C? No C, into D. D is R minus K. So this is A into B into C into D with the respective powers. Now from the coefficient given in the question, we have to find out coefficient of A to the power 6, B to the power 4 and C to the power into C to the power square, C square. So the coefficient of this product. So in order to find out that, we have to calculate the value of R and K. So let us compare the power of A, B, C, D with the following, right? So obviously for the power to be 6, R should be is equals to K. So minus R is equals to K. B is R and the R is 4. So R is equals to 4. C is square, right? That means 6 minus R is equals to 2. 6 minus R is equals to 2 implies, obviously R is 4. So we don't have to calculate it again. We know that R is already 4. We have to find out the value of K basically. Right? So if R is 4, so 6 minus 4 plus K, right? So A to the power 6 and R is 4. So from here, 6 minus 4 plus K is equals to 6. So K is equals to 4. Right? So that means R is equals to 4 and K is also 4. Now that means the coefficient of the product we have is coefficient. Let's find out the coefficient. B to the power 4 and C square is, now 6CR is 4 into 8CK is also 4. Now let us solve it. That is 6 factorial by 4 factorial into 2 factorial into 8 factorial by 4 factorial into 4 factorial. Now so from the options we can see that these are almost same, we only need one term, that is c. So these terms are not so familiar, right? That is, we are not getting the same numbers. तो यहाँ पे हम क्या कर सकते हैं, हमारे पास 8 फैक्टोरियल 6 फैक्टोरियल तो है और 3 4 फैक्टोरियल भी है, तो एक 4 चाहिए और ऊपर 12 चाहिए. सो दिस इज सो इजी दैट वी कैन जस्ट मॉडरेट इट बाय multiplying and dividing it by 12, that is 12 by 12. Okay, so if we do that, what do we get? 12 into 6 factorial into 8 factorial by 12 into 2 factorial is 4 factorial. So 1 4 factorial 2 3 4. So 4 factorial to the power 4. Now that is the answer. So the option A is the correct answer. The next question from the series of our ISI question solutions is question number 7. So the question number 7 in front of you is given a polynomial that is px is equals to ax square plus bx plus c, and ABC are drawn uniformly at random with replacement from the set 0 1 2. So there is a set of three numbers 0 1 2 and ABC are drawn. So the total polynomials that can be drawn are A can be drawn in 3 ways, B can be drawn in 3 ways, C can be drawn in 3 ways. So 3 into 3 into 3 is equals to, there are 27 possible total polynomials that can be drawn. Now what is the probability that the polynomial has two distinct real roots? Distinct real roots means what? Distinct real rule means that the D should be always the root, that is b square minus 4ac should be greater than 0. That is, the roots will not have the same values, they will have different values. Now let us try to solve this question. First of all, let us write down what we are given. The polynomial that is given is ax square plus bx plus c is equals to 0. The number from which we can be drawn, ABC is 0 1 2. Now ABC can take total polynomial as 3 into 3 into 3 is equals to 27. Now talking about two distinct roots. In order to have two distinct roots, real roots, A cannot be 0. That means A will be either 1 or A will be either 2. Now if A is equals to 1, for the two roots to be distinct and real, we should have b square minus 4ac greater than 0. Correct? Now A here is 1. So let us put it here as 1 into c. So that is b square minus 4c greater than 0. So b square greater than 4c. Right? Now b square greater than 4c. So b square cannot be 0. B square should be greater than 0. That means b square should be greater than 0, which means c is equals to 0, for which b should be what? Either the b can take any value between 1 and 2. Why cannot we see 1 or 2? Because if c is 1, then b square is greater than 4. That means the value of b should be greater than 2, which is not possible because we have only 0 1 2. Similarly, if the value of c is 2, then 4 2s are 8. So again b should be greater than any value 2. So that means in order to be within 1 and 2, c should take the values 0. So if a is 1, c can take value this. So b can take any value 1 or 2. Right? So there are possibility of this. Next is if a is equals to 2, then b square minus 4 2s are 8c greater than 0. So b square greater than 8c. Again here implies c is equals to 0 because b square has to be greater than 0. So b will be either 1 or 2 because for any value of c greater than 0, that is if c is 1 or 2, then the b should be greater than 2, which is not possible. So what are the possibilities here? There are 4 possibilities for the roots to be real and distinct. So that means the probability is 4 by 27, and that is the answer. The next question, number 9, is a standard question, and it is about true and false about the statement question. So here we have to solve it by using the logic. So here it is given for a function from R to R and a subset of A of R. Define f of A is function of x for x belonging to A, and f inverse A is where x belongs to R and function of x is A. Now we know that generally when we take the intersection of these type of function, that is f of x inverse y is a subset of f of x intersection f of y. Okay, so now here there is an equality sign, so this is an injective function, and equality is not necessarily true. So for all subset this is not necessarily true. And second is inverse, and the intersection and union function always holds true for inverse functions also. And so for all subset of xy of R this holds true, right? So that is 1 is not necessarily true but 2 is true. So let us check the options. Both 1 and 2 are always true. No, it's not always true. 1 is always true, not always true. 2 is always true, 1 need not be true. So C is the correct option. Okay.